Hi everybody, welcome to one more of Mrs. John's lesson. Today's lesson is for year 12 physics and under the topic waves, and we are going to look at light and sound, and let's just compare the two. And first of all, I've just put them into two columns. Light is an electromagnetic wave, okay, and we're looking at visible light, and white light is actually made of a whole host of different colors, and white light is made of these colors. You've got violet, indigo, blue, and then you've got green, yellow, I don't have all the colors, and then you have orange and red. Now all these colors make up white light when they all added together. Now what we need to remember is that violet has a high frequency compared to red. Red has a low frequency. Now, because the speed of light in a vacuum is the same for all the frequencies or all the colors, the speed of light depends on frequency and wavelength. So if the frequency is high, then the wavelength is low. So that means blue has a high frequency, but it will have a smaller wavelength. So that means more of them fit into the same space, or you've got more of them going past a point in 1 second. That's the meaning of frequency. And red light, on the other hand, has a lower frequency, but the wavelength is longer. So that's what. So the color of light depends on its frequency. Now, the other thing is you could have bright light or you could have dim light. Now, the brightness of light is an indication of how much energy is carried by light. So low energy light is dim and high energy light is bright. And an indication of the energy of a wave is given by its amplitude. So the amplitude is what indicates the brightness of light. So if I have a box over here, and let's say blue is a high frequency, whereas red is low frequency. So there's blue and red. So high frequency, and if it's dim light, so you've got more of them in the same space. So that's your blue, but it's dim because the amplitude is small. Okay, whereas if I have dim red light, it's low frequency. So the wavelength is longer, but it's not very high. So there's your red, it's low frequency, and this is both dim because the amplitude is small. Now, if I want to show how do I do bright blue light or bright red light, okay, the frequency of blue or red doesn't change, but if I wanted bright blue light, it got high amplitude and still the high frequency. If I wanted bright red light, then I have bright red light. So the amplitude tells you whether the light is dim or whether it is bright. The other thing I want to draw your attention to is about the speed of light. Now, light travels fastest in a vacuum, and when light goes through a transparent medium like water or glass or diamond, which can transmit through, then it slows down. So light travels slower in liquids and even more slower in solids. It all depends on the optical density of the medium. So the harder it is for light to travel through a medium, the slower it gets. Okay, so that's about light. Those are electromagnetic waves. Now, as opposed to electromagnetic waves, we also have mechanical waves, and sound is an example of mechanical waves. Now, mechanical waves, the energy is transferred. Mechanical waves actually need a medium to travel through, and energy is transferred from particle to particle. So if you're looking at how quickly sound travels and you're comparing the speed of sound in water or air or in a solid, sound can travel through all those because they're all medium. It travels the slowest in air, and it travels faster in water or liquids, and it travels the fastest in solids. So it's quite different to how light travels. And the reason is, in air the particles are far apart. The forces holding the particles are not that great as compared to the intermolecular forces in a liquid. So liquids, the forces are stronger, so the energy is carried more rapidly. And in a solid, where the particles are the closest and the bonds are the strongest, that's where sound travels fastest. So sound travels fastest in a solid. Okay, this is one thing about sound. Now the other thing that I want to draw your attention about sound is about the loudness and the pitch of sound. So you can have soft sounds or you can have loud sounds. So the loudness of sound actually is an indication of the energy carried by the sound. So if it's got lots of energy, you're going to have a loud sound. If you've got little energy, then you have a soft sound. The other thing that I want to draw your attention to about sound is the pitch of a note. You can have high pitch or you can have low pitch. So you can have a high sounding note, the shrill high notes, or you can have the deep low notes. Okay, so the pitch depends on frequency and loudness depends on amplitude. Okay, so I've got both my dogs next to me. Here's one, Alfie, who I think, so that's my dog. Okay, yeah. All right. Okay, so the thing to remember about sound is that the pitch of a note depends on frequency and loudness depends on amplitude, because it is an indication of the amount of energy carried by the sound. So similarly, just like we drew for light, you can have a similar sort of diagram for sound as well. So if you want, so if you want low pitch and soft sound, so low pitch is low frequency and it's soft, so the amplitude is less. Okay, if you want high pitch and again soft, so high pitch is frequency is more and soft, the amplitude is less. Okay, and then again, if you need over here, if you want high pitch and loud, so high pitch and loud, so high amplitude and lots of them. And you want low pitch and loud, so that's low pitch and loud. So this is loud, this is also loud, but one is high pitch and loud, the other one is low pitch and loud. So I hope that helped you. Bye for now.